Now we're going to talk about parallel and perpendicular lines. Lines that are parallel, as you know, never intersect. Since they don't intersect, they have to have the same steepness, and thus they have the same slopes. Let's look at some examples of parallel lines. If you look at the one on your packet, if we take a look at the slope, which you remember as rise over run, and we draw a few of those stair steps, I can draw little teeny tiny 1 by 1 ones, rise 1, run 1, and if I go over to the other line, it's the same exact slope. As we rise 1, we run 1. So the slope of both of those lines is 1. They have the same slope. And this is always true of any parallel lines. If I had two lines that were vertical, like the y-axis, they would both have a slope undefined. If I had two lines that are horizontal, like the x-axis, they'd both have a slope of 0. Let's look at another example. A couple more examples. So pairs of parallel lines. Let's look at the slopes on these. Drop 1, run 2. Drop 1, run 2. Drop 1, run 2. So negative 1 over 2. So negative 1/2. And the other line, let's take a look at that one. Drop 1, run 2, drop 1, run 2, drop 1, run 2. Exactly the same slope, negative 1 over 2. There's another pair of parallel lines. This one drops 2, runs 1, drops 2, runs 1. So we have another negative slope, this time negative 2 over 1. And this guy does exactly the same thing, negative 2 over 1, so the slope is negative 2. So parallel lines have the same slope. Memorize that. Parallel lines have the same slope. Let's look at perpendicular lines. Perpendicular lines are lines that intersect at right angles. So if I take a look right here where these two blue lines meet, and I take like the corner of a piece of paper, I can see that that is a right angle there. Perpendicular lines meet at a right angle or 90 degrees. So let's look at their slopes. Let's look at these two lines, for instance. If I draw my rise and run here, let's see, we've got a drop of 1, 2, 3, 4, and a run of 2. A rise of 4 and a run of 2, or we can even make that shorter, 2 over 1. 2 over 1. So the slope of this line is 2 over 1. Let's look at the slope of this one. Drops 1, runs 2. Drops 1, runs 2. So negative 1 over 2. Slope of this line is negative 1 over 2. Alright, keep that in mind. We've got 2 over 1 and negative 1 over 2. Let's go to another pair of perpendicular lines and see if you can understand what's going on here. Here, this pair also intersects at a right angle, so they're perpendicular. Let's check out the slopes. Let's see, we've got, here's a stair step. Remember, your stair steps, you have to draw from one whole number point to another one. So it looks like it rises 3 and runs 2, rises 3, runs 2. So the slope is 3 over 2. That's the green line. Now let's look at the blue line. Let's start at a whole number point. Drop 2, run 3. Drop 2, run 3. So negative 2 over 3. So the slope of this line is negative 2 over 3. Alright, what do you notice going on here? Here's the slope of one line that's perpendicular to another line. We have negative 2 over 3 and 3/2. This pair, we had negative 1/2 and 2 over 1. Are you seeing a pattern here? If I told you a slope had a line of 3/5, would you guess that a line perpendicular to it would have a slope of negative 5 over 3? Notice the two slopes have opposite signs, one negative, one positive, and one is flipped upside down from the other. That's called inverse or reciprocal. Same goes here. One's negative, one's positive, and you flip one upside down to get the other one. That's called reciprocal. So as you look at your text here, the slopes have opposite signs and the slopes are reciprocals. So we put that all together and we say perpendicular lines have slopes that are opposite reciprocals. Two parts to that. Opposite for opposite sign, and reciprocal for flip it. Memorize it, and you won't have much trouble with the next section.